My name is James Hurley, and I'm the Senior Director of Alumni Relations for New York University. On behalf of the NYU Alumni Association, representing 500,000 alumni living around the world, we're excited to welcome you here to Shanghai this afternoon. I'm very excited to join you actually from Midtown Manhattan. First and foremost, we at NYU hope that you and your families are healthy and safe. We would also like to thank you for spending some time with us this afternoon to grow in learning from our collective NYU community. For those of you unfamiliar with the Zoom platform, we'll be using the Q&A function this afternoon to take questions. So please feel free to use the Q&A function at the bottom of your screen to pose questions to our panelists today. Before I introduce our three special guests from the Center for Data Science, I oftentimes like to look at the attendee list before these events. And today I'm pleased to report there's over 150 registrants that hope to join us. The session is being recorded and will be available for future consumption. Of the individuals joining us, we have one individual who's joining us who graduated NYU in the class of 1963 from the law school, the oldest alum on the line this afternoon. We also have 14 alums who recently joined the alumni community, graduating in the class of 2020. So a very big and warm welcome to those graduates as well. We're excited to have you. This afternoon's presentation is going to involve a brief overview of the Center for Data Science by our faculty member, Professor Julia Kempe, as well as a conversation with the lead researcher for Breathe for Science, also housed principally at NYU's Center for Data Science, Professor Kyun-Yoon Cho. And with that, I'm excited to introduce my colleague, Lorraine Nascimento from the Center for Data Science to introduce Professor Kempe.
Hi, thank you, James. That was a great introduction. And just to kind of piggyback on what you said about the 500,000 alumni out there, I'm glad to report we're officially over the 400 mark for CDS, the 404 alumni, and also across the country and globally as well for us. So really excited about that. For those that don't know me, my name is Lorraine Nascimento. I'm the head of external relations and career development at the NYU Center for Data Science. So most of you CDS alum have worked with me, or we've chatted at some point, and so I'm happy that I was able to send you guys this invite and get you guys all on the line. Thank you for attending, and I'm going to go ahead and introduce Professor of Computer Science and Mathematics, as well as our NYU Center for Data Science Director, Dr. Julia Kempe, to give the overview of CDS.
Yes, hello and welcome, and good afternoon, also good morning and good evening to all of you in the various time zones. So thank you very much, Lorraine and James, for the wonderful introduction. My task is to introduce our speaker, which I will do in a second. But before I do so, because we are such a new institute, I will spend a few minutes introducing the Center of Data Science to those alumni who are not data science alumni. James, can I get the next slide? The Center for Data Science is a provostial center, which means we don't belong to any school. We are our own unit embedded in the fabric of NYU, founded in 2012 with the express mission to create and then a world-leading data science research and education center. The center has grown from 0 joint faculty to now 17 joint faculty over the last 7 years. And it has become the focal point for NYU data science and big data research. On the right of the slides, I have flashed some research directions that our faculty pursue. There are technical areas, machine learning, perception methods, natural language processing, but there's also, we have joint faculty with the sciences and also the social sciences. There is, of course, theory being developed. There's data management. We are big and responsible data science. and we have very fruitful connections to the medical school. Next slide, please. So what is data science? It's a very new field that is still being defined. Our take on data science, it enables us to extract knowledge from data. And we have a vast net of affiliates and collaborators all over NYU, so that we've become really a data science commons for everybody who wants to do data-driven research. We run numerous events and that try to connect the schools and units. And we have a large network of faculty and researchers. So what are we trying to achieve? We're trying to move forward and fertilize data science methodology to transform the process of discovery. But at the same time, we also get feedback from the discoveries to implement new data science methodologies. And this way, we're trying to achieve a virtuous cycle of knowledge creation. Next slide. In these few years in existence, we have, as I mentioned, grown to 17 joint faculty, which fulfill both the research and the teaching mission. At this point, we have 301 master's students, and as Lorraine said, 400 alumni, or more, over 400. 31 PhD students growing. We are now teaching undergraduates, over 250. I think that number is probably close to 500 in the next year. We have postdocs, so junior researchers. We have a large net of affiliate faculty, visiting faculty, and associate faculty, all connected through this theme of data science. And without further ado, one of our most senior researchers, even though he's very junior, perhaps on a scale of research, it is my big pleasure to introduce Associate Professor of Computer Science and Data Science, Kyun-Yoon Cho. Kyun-Yoon Cho has completed his PhD in Finland, actually, but then worked at the University of Montreal as a postdoc in natural language, neural machine translation and natural language processing. And he was one of the inventors of what is called now the attention mechanisms, which drove forward this type of research to unprecedented heights. Kyun-Yoon's work is very, very broad and also very prolific. He has worked on practically every area in which we have some joint connection. Of course, he has written many papers in natural language processing, but he has also joint papers in biology, in physics, even in politics. So he is one of our broadest researchers, but at the same time, he is an example of what data scientists do, namely apply tools and methods everywhere and create new tools and methods. His work has been honored by many best paper awards, which I will not name in detail, but he has been a Google faculty fellow not once, but twice already. And he's a CFAR Global Azrieli Scholar. As COVID descended upon us 3 months ago, Kyun-Yoon immediately employed his prolific skills and has mounted 2 amazing projects to deal or to help with COVID and to provide information and to show that data science plays a big role, hopefully, to help us create a better world and to combat this problem at the moment. So these 2 projects, and I don't want to steal the show, so I'm just going to mention them. One is called Breathe for Science, which is joined with the PhD students at the Center for Data Science, and the other one is Neural COVID-X. So without further ado, Kyun-Yoon Cho.
Well, Julia, thanks for the generous introduction. I think it was much more generous than who I actually am. And thanks for the invitation, James. And it's happy for me to be here and then tell you about what I've been working on, especially regarding the COVID-19 and the pandemic that has really descended upon us without any kind of advance notice. So before I start trying to answer any of your questions, I'll give you a very brief the introduction of these 2 projects that Julia just mentioned. So one of them is called Breathe for Science. The idea all started from one of the PhD students that I advised at the NYU Center for Data Science, William Falcon. So he one day just talked to me very casually on Slack. It was March 20th. Asked me if there is any way for us to use some of the open technology and science that we have been developing at the Center for Data Science in order to help the medical professionals as well as the researchers in trying to come up with a new way to do the remote diagnosis of COVID-19. And then we were just brainstorming, and then eventually we realized that in fact, how we have been operating, that is to make all our scientific as well as the technological outcomes open source, allows us to build rapidly a platform over which people can participate voluntarily and then provide the data that could be useful for perhaps this pandemic or even next pandemics. So over the next 1 week, starting from the March 20, William Falcon and I built a very quick platform that's going to allow people to come to the website and then type in their phone number and then answer some of the questions. And then this website is going to automatically call the participant and then ask them to record their breathing patterns as well as a coughing pattern. And it took us exactly 7 days until we launched this whole service, which was possible because we used all those open technology and science components. And then for the next 4 weeks, we were able to collect enough data using just a phone calls. And then we were able to conduct a preliminary analysis together with our collaborator in another university, using, in fact, the LibRoSel, which is the open source library that is actively maintained by one of the faculty members at Stanford Data Science, Brian McPhee. And then that turned out that this analysis showed us that indeed these breathing patterns that can be easily recorded by a simple phone call, which makes it extremely scalable and then applicable to all over the world, can give the physicians some idea about the underlying respiratory let's say conditions the participant has. And then since May 3rd, and then on May 5th, this whole project was I was working together with my collaborators in Korea, and then we applied for the grant to the Korean government to collect a larger scale data using more or less ubiquitous app in Korea. And then that was funded. And then at the moment, we are actually collecting even more data in order to prepare for the next pandemic. So James, can you go to the next slide, please? So that was Breathe for Science. Now that's the one part that I have worked with together with my PhD students. However, of course, what we can do as a data scientist, especially working on this open science and open technology, is to make the data even more accessible to all those medical professionals and researchers who may not have the technology or the algorithms that we have available in ourselves. So on March 13th, so it was more or less the same time, I started talking with my longtime collaborators, Professor Jimmy Lin at University of Waterloo, and my former PhD student, Rodrigo Nogueira, who is now a postdoc at University of Waterloo and who's coming back to Brazil in order to become a professor there. And then we started discussing what can we do in order to make all those vast amount of data that is ever growing more accessible to the medical researchers and professionals. And around that time, simultaneously, Allen Institute for AI in Seattle released a large amount of data that consists of the papers that are very much focused on COVID-19 and related disease. So we create a team, like in a couple of days, and then started looking at what are the technologies that we have built over time that are available openly, and we can quickly build into a usable service that can be served to medical professional researchers as without any hurdle. So all they need to do is simply open the web browser, type the keywords or the question, and our system is going to answer that based on the data released by the Allen Institute. And it turned out that what we have been working on over the past many years at Center for Data Science, as well as the University of Waterloo, in fact, were enough to build this system rapidly, building in all those state-of-the-art deep learning techniques within a week. So starting from the March 21st, when we started talking about this collaboration, and by April 2nd, we had the actual working service online that is accessible by anybody in the world. And then we have been updating this system with more and more features based on the feedback we've been gathering from the medical professionals as well as the researchers. And then we have a very steady stream of the users every day. And then we get about 4,000 or more unique users every month. And then we plan to continue to push the boundaries so that we can provide a seamless access to the ever-growing amount of the medical articles to the medical researchers. And then, these two are the, that's about it for on what I have been doing for the COVID-19. And then, I'm happy to actually receive some questions if there's any questions from the audience.
So this would be the moment. Feel free to enter your questions into the Q&A box that you see, and I will bring them to Kyun-Yoon Cho. While we're waiting for the questions, let me maybe start the conversation by pointing out, Kyun-Yoon, that twice you have said within a week we built such and such. So I'm presuming that you leveraged a lot of the tools that were available open source, and that might or might not have been managed. You said there was a tool managed by Brian McFree from the Center for Data Science. So universities play some role in it. Could you elaborate on the role of open source tools and universities in this type of research?
Julia, that's a great question. And in fact, it works perfectly with the message that I wanted to convey, is that we were able to build these tools rapidly within a week each, because all the technologies that we have been in fact developing. So in the case of the neural COVID-X, there is the keyword search engine that is full of the information retrieval algorithms. There is the neural re-ranking that is based on the deep state-of-the-art deep neural networks. And then there's unsupervised sentence highlighter, which actually was built out of scratch by me and my collaborators during the 1 week. And then all those technologies that we've been building as part of NYU Center for Data Science, and in the case of my collaborators Jimmy Lin and his students at University of Waterloo, we've been putting everything publicly available so that anyone can use it. And it turned out that we could use them ourselves as well. We could just take all those things that we have been pushing out and then rapidly put them together in order to create a usable service that is not only just as a product, but that is in fact beneficial to everyone who is actually struggling against this pandemic that has been put upon us. So what I want to point out is that it's not the university's role itself, but in fact it has been the university's role that has been crucial. So what we have been doing is to focus our entire effort in the science and then the education. And then as a byproduct, we've been open sourcing everything that we have created ourselves. And then that actually allowed us to build all these systems, there's at least the 2 systems that I showed you, within a week, because we've been opening everything. There are a lot of similar services along these 2 projects that I've shown you from in fact, the for-profit companies, but it actually took them longer because we are more adapted, trying to put everything open and then try to use all those things that are publicly available out there. So in that sense, I think the universities, so we have been crucial component that enable this rapid deployment of the open science platform for COVID-19.
Thank you. That is a wonderful answer, which shows, I think, that universities in these times can take a lead role also to help fight the pandemic. I am getting more and more questions, so let me start posing the questions that come here. One question asks, what specifically do you look for in the breathing patterns data?
Yes, this is a really interesting question. I must confess that I'm not the best person to answer this question, as I'm a data science rather than a physician. However, so how we actually designed the whole Breathe for Science project was in consultation with some of my peers who are at the medical school, and then some of my longtime collaborators, either at the NYU Medical School or at another medical school or hospitals. And then what you notice, in fact, is that one of the major symptoms of COVID-19 is the respiratory condition that deteriorates quite rapidly. And then it has been a common practice for any physician to try to listen to the breathing patterns. And then that is actually one thing that doctors have been practicing. So what we wanted to do was whether we can, in fact, apply the remote, let's say, tools to ensure that the physicians can listen to the breathing patterns without having to come in the physical contact, which is one of the very important vectors in transmission of the SARS-CoV-2. So what we wanted to do was to try to present an opportunity that was not present before, but for the future, so that the physicians will be able to use this information in order to make a remote diagnosis better. So in that sense, I cannot really tell you what are specific patterns that we are looking for. Of course, we found some of the patterns ourselves, but what I can tell you is that this opportunity that we were able to create by using the insights from the data science has been useful, and then I hope that it's going to be useful in the future.
Thank you. So another question asks, you talked about using your technology to gather data in Korea, but has it been used in the United States already or as well?
Yes, this is also an interesting question, because our goal, so we in fact have a design document that we created as we are creating this Breathe for Science project. And then you can actually find it in breatheforscience.com. Now, one goal we had was not to in fact collect the data extensively ourselves and analyze the data and perhaps coming up with some kind of product. Our goal was to present to the world that this is one avenue that we can pursue, and then this could be useful in the future. And then in order to do so, what is the right and also rapid way to do so? In fact, we have done a trial run of the data collection twice, once with the breathing patterns and the coughing patterns. And then the first analysis we have done was using the breathing patterns. And then we have seen something, but during those 2 periods of data collection, what we received a lot was the context from the various, let's say, people who have interest in trying to deploy this system in their own communities or countries. So we got contact from people in India, we got contact from people from France, and so on. And Korea was one of those countries where people there contacted me about. So what we are doing in Korea at the moment, it has been for me to advise their effort, and because we have a prior experience in data collection. So what we are now doing is we chose the Korea as a partner, because Korea actually does present a pretty unique place where let's say the use rate of the high-end smartphone is almost more than 100%, and then almost everyone uses the same app. So it makes it much easier for us to rapidly deploy this platform and then collect the data as quickly as possible. So that's what we are working. But whenever we get any requests for the advisement or some kind of collaboration, then William and I are open to in fact talking with them so that the system can be deployed all over the world. So one thing I wanted to point out is that this Breathe for Science, we focus on just a conventional phone, because we noticed that in developed countries, you always find people using smartphones, and then you can always deploy the apps and then get a higher quality breathing pattern recordings. But as soon as you go out of the developed countries, you do see that the people just do not have those high-end smartphones, nor the 3G or the 4G networks sometimes just do not exist. So we wanted to go for the most scalable solution. And then I believe we have demonstrated that it is possible. And then hopefully it's going to be useful not only in these developed countries, but also in many of the developing countries.
Wonderful. That segues to the next question, namely, what platform did you use to collect the breathing patterns? And was there any concern on the accuracy of the recordings with respect to noise pollution, which you already mentioned?
Yeah, this is a great question. I mean, I think that was precisely the question we also had at the beginning of the designing phase of the Breathe for Science, because the reason why we created this Breathe for Science was in fact to answer this kind of question. Is there important or the useful signal in the breathing pattern when it was recorded over this kind of conventional phone systems, which has a very limited bandwidth? And then your idea, what is the right way to approach people so that they're going to record the breathing pattern with a minimal amount of the background noise? In fact, what we have found when we were analyzing all those, the recordings, was that there are a lot of noise. There's a lot of background noise, and also even that people have different ways to breathe themselves when we don't actually tell them what is the right way to breathe. So, and then, all those lessons that we have learned have been incorporated into this current ongoing data collection effort in Korea. because I actually went through this process, and then I was able to advise the more kind of professional data collection effort that is happening in Korea by the grant from the Korean government. And then I could tell them what are the pitfalls that we expect and that we have in fact already experienced. And I think this is the optimal outcome that we actually hope for when we launched Breathe for Science. That is, let's try to check the feasibility of this approach so that if it turned out to be feasible, this can be scaled up by more professional organization or the organization with a better reach to the various populations.
Thank you. So I want to pivot a little bit. There is a few questions here that deal with privacy and transparency. So there is always a concern with data science to do it responsibly and respecting the privacy, obviously, of the people from whom this data is coming. So how do you go about doing your research in a place like Germany where this is very strictly regulated? I guess the whole European Union it has different privacy regulations. And also, how do you make the data transparent? And how do you deal with verification of that?
Yes, that's true. I mean, there are actually two aspects to that. So first aspect is that as I mentioned just now, is that our goal was to demonstrate the feasibility of using breathing patterns recorded remotely for diagnosis of these respiratory conditions. And then one of the reasons why we do not actually claim to nor plan to do the extensive data collection and build any kind of analysis product ourselves, because we believe that this kind of service and the software analysis has to be localized, not only in the legal terms, but also because there are cultural differences in how you cough or how you breathe. And then there are differences in how the lifestyles that may affect the different, let's say, compounding factors that we need to control for. So in that sense, let's say the issue of the legality or the legitimacy of such a data collection procedure needs to be localized, and that has to be done by the local authorities or the local players. And then the second aspect of the privacy, this is really important. It's not only about Germany or EU, but the US as well. We have a very strong, let's say, regulation for collecting private information and then even storing them or analyzing them. So that's why we have the institutional review board and everything. So from the very beginning, you can check from the design document of the Breathe for Science, we ensure that this project focuses very much on feasibility, and then not to trying to do any kind of diagnosis for the individual participant. So if you go to breatheforscience.com, one thing that we had to ensure is that no participant is going to be misled that they're going to hear anything about the actual outcome of the analysis. So no one gets that. And then that actually removes, to a certain degree, the selection bias that in fact often plague a lot of these studies based on the human participants. And also we made sure by going through very painful details into all those services that we use, that none of the person identifying information is stored anywhere. In fact, we cannot even come back to any of those participants because we don't even store the phone numbers. We do store the one-way hashed phone numbers in order to ensure that we can actually track if a certain person is participating multiple times over the 2 weeks of the period. However, we cannot really decrypt it, well, unless the NSA in fact has the decryption of all those one hashes. So we cannot decrypt it. So yeah, so we have spent in fact as much time in trying to ensure that our study does not break any kind of privacy law as we spend on designing the whole project. And also we believe that all these things need to be localized. For instance, like the collaboration with my partners in Korea. So they are sticking to the Korean privacy law in order to make sure that the data they collect is not going to violate any of the local laws, and also to protect the privacy of the participants in Korea as well as possible.
Thank you very much. This is a very broad topic indeed. I want to, I think, finish up with one more technical question, which asks specifically for the recordings. They are done on different phones, and different microphones are being used, different background noises, different frequencies. How do you standardize this, or how do you do it given the amount of different data for each person?
Yes, this is actually I mean, somehow all the questions are awesome in the sense that these are all the questions that we have been thinking a lot, and then we are still thinking about how we can actually answer this. So one of the things that makes it easier if anyone builds this kind of breathing-based remote diagnosis tools using apps is that the smartphone apps can control a lot of things, and then smartphone apps can know much more about what kind of phones or the microphones that each individual smartphone has, and then based on that, you can do a lot of calibration on its own. On the other hand, our goal was to check the feasibility of the most scalable approach. That is not most scalable within each nation or something like that, but most scalable across the different continents. So we wanted to check the feasibility of using a phone line, usual conventional phone line, without assuming anything about the actual phones. So as we have seen from all those recordings during our analysis, that does pose a unique challenge that you would not run into with those app-based recording or the collection. However, we believe that this still embeds, or these kind of recordings still have some frequency-based signal that can be used to tell whether the person has some kind of underlying respiratory condition or not, even if the participant did not know in advance. So what it means is that we will actually need to do further studies. And then what we hope actually with this the data collection in Korea, where we actually plan to record or have the participant of at least 15,000. I think that at that kind of scale, we will start be able to tell whether we can get even a tiniest bit of this signal from this gigantic amount of noise that we can get from even app-based or the phone-based recording of the breathing pattern. So yes, to be seen, but I'm more hopeful than when we started the whole project about a month and a half ago, or actually 2 months ago.
And on that hopeful note, I really want to thank not only Professor Cho and Professor Kempe for joining us, but the entire Center for Data Science team, particularly Lorraine for joining us this afternoon. It was an absolute pleasure to hear firsthand from some of our NYU faculty researchers who are really thinking about this day in and day out. From the Alumni Relations Office, it's always a pleasure to connect with so many of you. I think I saw a high of nearly 100 folks on the line this afternoon, so really wonderful that you all spent some time with us together. For those of you interested, of course, here on the left-hand side of the slide, I would encourage you to follow the NYU Alumni Association on Facebook, LinkedIn, Instagram, and so forth, as well as update your contact information on our website if you'd like to receive future correspondences moving forward about related content. We host over 700 events a year. This is one of them. If you're interested in learning more, please do join. And on the right-hand side of the slide, of course, the Center for Data Science maintains their own social media platforms as well, including Facebook, Instagram, and Twitter. I would encourage you to visit them as well. And of course, for those of you interested and able, please consider making a gift to the NYU Emergency Relief Fund. To date, we have dispersed over $4 million to students across the university who have been impacted by COVID, who have to move home, and always looking for our alumni and donor community to help support make that a reality. So with that, I will wish everybody a very happy afternoon or a very, very early good morning if you're joining us from the Asia Pacific time zone. And we'll look forward to seeing many of you again. So again, thank you to the Center for Data Science, to Professors Kempe and Professors Cho, and of course my colleague Lorraine Nascimento as well. Enjoy the afternoon, everybody, and we look forward to seeing you again soon. Take care. Bye-bye.
Thanks. Bye.
Bye-bye.